This question says, what this question is: figure shows a particle sliding on a frictionless track which terminates on a straight horizontal section. If the particle starts slipping from point A, how far away from the track will the particle be vertical hit the ground? Okay, so first particle, if it is allowed to slide from this point, starts slipping from point A, it starts slipping and it will come here and it will acquire some velocity. When it is reaching at this point B, okay, suppose this is point A and this is point B. When it reaches to point B, the particle will acquire some velocity, and as a result of that velocity, the particle will fall, and it may fall at some distance. Okay, so this distance we needed to calculate. Okay, so how far from the track will the particle hit the ground? So this x we need to calculate. Okay, so what is happening? The object is allowed to slide from point A. It will slide on the smooth incline. As it reaches to point B, it will acquire some velocity, and because of that velocity, it will hit the lower ground at some distance. So that distance x we need to find. So for this, first we will see, as it moves on the incline, what are the different forces acting. So one is mg, second is normal. Okay, and since it is smooth incline, there is no other force. So what we can write from A to B, we can use the conservation of energy. Why? Because work done external, if you see the work done external, we have only normal force. There is no other external force, and normal work done will be 0, because normal is like this and displacement is perpendicular to it. Okay, so normal and displacement are perpendicular, so work done by normal is 0. So if work done external is 0, the delta k plus delta u equal to 0. Okay, so how much is delta k? So how much is delta k? The delta k, the change in kinetic energy. So change in kinetic energy is initial speed is 0 and final here is suppose v. So we'll write half mv square minus half mu square. Okay, this is change of kinetic energy. Now change of potential energy. So object has declined. Declined by some height. Okay, it has descended by some height. So from 1 meter to 0.5 meter. So mg final height is 0.5 meter and initial height is initial height was 1 meter. So this thing we have to do. Okay, so this is 0. So v square we are getting as 2g 1 meter minus 0.5 meter. So this much we are getting under root. So now we put the values 2 into 10 into 0.5 under root. So this is root 10. The velocity of the object which we are getting is root 10. So this is the velocity of the object. So after that, if we get this velocity, this is the velocity. So after that, we have to see it as a projectile. Okay, so if you consider this projectile and this velocity v is horizontal. Okay, so after point B, the object is projectile. Object becomes projectile. So in vertical direction there is no velocity. So what we can write is, in vertical direction there is no velocity. So the height which is 0.5 meter here, the 0.5 meter will be traveled with starting with 0 initial velocity. So that h we can write as half gt square. Okay, so h is 0.5 and half g is 10 and t square. Okay, so we can write t as under root 1 by 10. So this is the value of time. So in this much time the object will fall on the ground, and in the same time the object will moving horizontally with velocity v. So distance x we can write. Now we are writing horizontal equation. This was vertical. This is vertical equation. Now we will write horizontal. So horizontal equation will be what? X equal to v into t. So v is root 10 and t is 1 by root 10. So finally we are going to get 1 meter. So at a distance 1 meter, the object will land on the ground. Okay, so in this way we find